Hello everybody, today we're talking about facades. And as you remember, we had a vertical load-bearing part already. So this can be the facade actually. If I'm making my building out of lightweight bricks, the load-bearing part will be an essential part of the facade as well. And what I also can have is to have a load-bearing structure, very current situation. And then I will insulate this, and then I need some sort of cladding for the insulation. So this is what we have very often. Instead of a cladding, I might have a second wall, so that I get a cavity wall. But building physicists prefer to have the load-bearing structure on the inside. So in this case, the load-bearing part of the wall and the insulation have been separated. You can hear this very clearly. So the alternative might be to insulate on the inside. Then I have to deal with the thermal bridge at this point. So this is something which is often used for renovation purposes if I add insulation to an existing building. And as a new building, this is not so popular because we have to resolve the thermal bridge here. And this means to cut here the floor slab where it wants to transmit the load to the vertical load-bearing element, and that's an additional complication. What some people are trying today is to use massive wall building materials that incorporate the insulation. So in this case, the building material is so insulating that I don't need a specific insulation in addition to this. And in this case, the mineral wool insulation is in the inside of the brick wall, so you don't seal it, you don't feel it on the outside, but it's incorporated in the brick. So today we are going to treat the exterior insulation and then the protection of this exterior insulation. I'm standing on a floor right now, and this floor has to be supported, and then I need an interior surface. There might be an interior insulation, there might be an exterior insulation, there might be a protection of the exterior insulation. Then I might have sun shading devices where I don't have the closed parts, and there might be a load-bearing structure against the wind. So in some constructions I separate all of these different functions. In others, they might all be integrated, as for example in a massive concrete lightweight wall. So that's considered by many people as being simpler as separating the facade in different layers. Behind me you see a load-bearing brick wall. So that is part of the load-bearing system and part of the envelope as well. And on the brick wall you can see anchors where siding is going to be fixed. And in between the siding and the brick wall is going to be the insulation that you see here below. You can see the brick wall with longitudinal bricks which are doubled up, and the other one putting laterally to them so that they form a bond. So I suppose this wall is going to be 2 bricks thick. The bricks are a lime-based product which is not insulating. So I believe that this building has been insulated with an exterior insulation before. The main load-bearing effort is fulfilled by these bricks. And I will show you another example right next to this, which is the extension. And the extension has been built with another principle. So behind me is the extension, and you can see that there are holes in the wall. Why are there holes in the wall? Because there's a cavity behind. It's a cavity wall with a load-bearing interior part and surface part that is visible on the outside. So this brick wall here, although there is a bond, Flemish bond indicated, it's not load-bearing. And behind it is an insulation, and it's just a cover for that insulation. Same for the prefabricated concrete part in the lower part. So behind me there's concrete load-bearing structure, no joints visible, so I think it must be load-bearing what we see. And there's brick infill, which was quite popular during the 60s and 70s in Germany. So if it's insulated, it must be insulated behind the load-bearing level. So behind me, another building of TUM. You can see a lot of joints. So in my opinion, this is a facade cladding, which is rigidly linked to the load-bearing structure behind. And there should be concrete pillars behind those that continue through all the stories. And there are others which are not continuous, so behind those there will not be a load-bearing structure. So in the intermediate part you see a window wall. So it's rather something as a window and not so much as a wall. And the load-bearing function is not fulfilled by what we see. It must be done somewhere else. So here we have an industrial building which has a load-bearing steel structure. And you can see that the envelope here is flush with the steel structure. So in thermal terms, that's not the optimum. This is a 60s building, but what they did very nicely is to show the joints of the bricks in a continuous way, so you can really see that it's not load-bearing. There is no bond. It's an infill material which has been signified by these continuous joints. Behind me you can see that what seems to be brick is not always load-bearing brick. In this building here, as the corner is very slender, there has been concrete reinforcement on the inside, and this concrete reinforcement contains metal bars. The metal bars have been rusting, expanding, pushing off the brick veneer. And you can see that now we have here a building incident and has to be repaired in one way or the other. And the historical monuments people do not know yet how to repair this, because the original look was massive brick for these angles. So you have seen the final result. Behind me is the construction site. The construction site shows the load-bearing elements very clearly, made out of reinforced concrete. And where you don't need the reinforced concrete, there's brick infill. The whole thing will be insulated and stuccoed afterwards. So there's a lot of plastic products being used in the building process. You have the protective plastic film put in front of the cellar insulation. The green plates behind that are waterproof insulation. And behind that you have air tightening film around the openings to be sure that there's no air exchange between the interior and the exterior. So there are many insulation materials. This is one of them, not very good insulation. It's wooden wool, and it has been petrified with cement to make one of these Heraclit facade panels, which were a long time used to insulate the fronts of floor slabs in a load-bearing facade. This is a modern lightweight brick with a perlite infill, which is also used as an exterior insulation if you don't want to put the stucco directly on the insulation. This is an alternative. So in front of me we have different types of insulation, and this insulation can be covered by wooden siding or aluminum siding or something like that, but you can also put a stucco directly on it. So here you can see that this stucco has different parts. There's a base material, then there's a reinforcement integrated here, and then there's a final layer which gives the color to the stucco as well. And as insulation materials, we have a wood-based plate here. This is styrofoam based. Here we have polyurethane containing a lot of primary energy, so this is what we're trying to avoid. Or here, a straw-based insulation material, which is not applied very often because the insulation value is not very high and the supply is limited in Germany. Here's some more extravagant insulation materials like cork, but there are not enough oaks in Spain to produce enough cork for the German insulation market, so this will always stay marginal. And this is something very high-tech, vacuum insulation panel. So there's a vacuum in the inside. The only disadvantage is that the vacuum is rather fragile, and it often starts to leak, and then air gets sucked in and the thing becomes less efficient. So it is very often combined with conventional insulation plates to make it more fail-proof. Here two other high-tech insulation materials for the inside of a glazing. This is transparent insulation that avoids the circulation of air on the inside of a glass panel. So it's transparent, you can see me. So here we can see many different insulation materials on one wall, from the mineral wall to cotton, and that exists, has to be well protected, but it's used more and more often for insulation purposes. Here up-to-date styrofoam with graphite on the inside, foam glass, another mineral wall, wood-based material. Here rather coarse wood-based material with cement reinforcement. This must be some sort of plastic material. So there are many alternatives, and we have to apply more specific criteria to choose one or the other. So for facades it would be in most cases a mineral wall nowadays.